All right, so today we are continuing in 8.2, the reciprocal function family. Now today we are moving on from the very basic parent function. So yesterday we talked all about graphing this beast right here, okay? Today we're going to look at ones that have those translations in them as well. So now we're using x minus h to represent our horizontal translation, k to represent our vertical translation. And again, remember, x is always acting oppositely from what we'd expect, and k is always doing exactly what we expect, just moving it up and down. So when we're plotting these, the first thing we're going to do is we're going to plot our asymptotes, okay? Just like what we did yesterday. Now, keep in mind though, because we're shifting, that also means that our asymptotes are shifting. So what I mean by that is, so here, see that x plus 1? That is shifting 1 to the left. So because it's shifting 1 to the left, it means my vertical asymptote is shifted 1 to the left as well. So my horizontal asymptote is going to be sitting there, meaning my domain is all real numbers, except this time x can't be -1. My horizontal asymptote, well, again, note there that -2 at the end. So that means I have a horizontal asymptote at -2. Remember, that's shifting it 2 down. All right? And so the horizontal asymptote will follow that shift downward. And again, the range will be all real numbers, except y will not be able to be -2. All right, so that's kind of our most basic thing. Now you may be wondering, well, how do I know about the points? So look at step number 2. Pick two x values, one to the right and one to the left of the vertical asymptote. Find the corresponding y values. All right. So this time we're only going to pick 2 points, just so we get an idea of which quadrants these are in, and then we'll graph them. So my vertical asymptote is sitting at -1. So that means the two values that surround it are -2 and 0. So you always look to that vertical asymptote, pick one x value to the right, one x value to the left. And now I have to actually calculate those values. So I plug in -2. So think of 1 over -2 plus 1 minus 2. So I'm plugging in that -2. Well, right here, -2 plus 1, that becomes a -1. 1 divided by -1. Well, that's going to become a -1. -1 minus 2 is a -3. All right, so I have that first point. Now I'm going to plug in 0. All right, so that basically becomes 1 over 1, right? Because that will simplify to 1. 1 over 1, well, that's just the number 1. 1 minus 2 gives me a -1. All right, so I have my 2 points. So I'm just going to plot those 2 points right there. So -2, -3 puts me right there. And 0, -1 puts me right there. So the reason I need those points are showing me which quadrants those branches are in. And now that I know that, now I can just use the rules of asymptotes. So I know that my graph is just going to go off approaching each asymptote forever. So I have to go through that point I just found, but I know that I'm going to start approaching those asymptotes. And that's how I can end up finishing off these graphs. Okay? Now, because the numbers will start getting messy, notice we're ignoring the x and y intercepts right now. Our main focus is finding the asymptotes, labeling domain and range, and then just kind of plotting approximately where the graph would be. So, let's do another one just to keep getting an idea about how to do these. So, I have a vertical asymptote, okay, where my x is shifting. So my x is shifting 4 to the right. So remember this, that's telling me to go right 4. So my vertical asymptote will be over at x equals 4. It's being shifted over 4 to the right. My horizontal asymptote, well, there is a shift 6 up. So my horizontal asymptote is going to be up at 6. So those are always the first things that you want to do. You want to shift around your graph, shift those asymptotes. So my domain is all real numbers, except where x can't equal 4. Range is all real numbers, except y can't be 6. All right, now we have to pick 2 points. All right, so I'm going to pick 2 points around that vertical asymptote. So I'm going to use an x of 3, an x of 5. I want 1 on each side of that vertical asymptote. So I get an idea on where those, where my points are, which kind of quadrants my branches end up. So I'm going to put in a 3 first. So by putting in a 3, I get 1 over 3 minus 4 plus 6. Well, 3 minus 4 gives me a negative 1. Oh, sorry. I skipped a step there. 1 over negative 1. Well, 1 divided by negative 1 is just going to be negative 1. Negative 1 plus 6 gives me 5. All right, now let's do our next one. Let's plug in 5. 5 minus 4, that gives me a positive 1. Well, 1 over 1 is just 1. 1 plus 6 gives me 7. All right, so I have my 2 points. Let's see where those ended up. So I have 3, 5, and 5, 7. So now that I can see where those 2 points lie, I know what quadrants my branches are in. So all I do is I extend my graph to begin approaching those asymptotes. And my graph will look like that. Now the cool thing is, now we know how to graph them. However, that's not the only thing we can do with this. Let's say I know my translations. I know where those asymptotes are. I can actually rewrite the function, okay? I can create a function based on that. So let's look at these 2 graphs right here, and I'm going to move them up to give myself some more space. So the idea here is if you know what that a value is, what that stretch is, you can write the equation of a transformed reciprocal function. So both of these are based on that parent function of 2 divided by x. So I know that that stretch is 2. Now, let's take a look here. So it looks like in each of these, notice the scale, all right? The scale, every one of these is counting by 2. So this here is at x equals -3, and this is up at y equals 4. So if I know where my asymptotes are, I can go back and I can write the function from it. Y equals, now it's telling me the parent function is 2 over x, so that tells me I need that 2 up there. Well, to shift x to the left, remember x is always opposite what we'd expect, and the y is what we'd expect. So all you do is fill in those pieces, and you're already done. All right, let's look at our next one. So again, if we're counting by 2's, that means that our vertical asymptote is at x equals 1. Horizontal asymptote down at 4. Our parent function here is the same, so we still have that 2 there. But now to shift x 1 to the right, remember, is the opposite of what we'd expect. And then the y acts exactly as we'd expect. And there we have it. All right, so that is actually all for our notes today. A little bit of a shorter video. So what I need you to do, as always, please make sure you have everything written down because tomorrow you'll have to come back prepared to do our practice work on this.